So in this session we are going to learn what is traversing of a list. So to traverse a list means you are going to go through the node, right? So go through the node and read the value and print that value, right? So as you can see, there is an example I have taken. So these are the nodes, 1, 2, 3, these are the nodes, and 4 nodes are there. And let's say we talk about the first node. This is the address at which this particular value is stored, and the next is a link is storing the address of next node, right? So next node is at 250 and the value is, or you can say the data is 11, right? So what if I want to traverse all these values? Means I will access all the nodes and I just simply access the data part and just print these data, right? 25, 11, 5 and 12, right? So as you can see, there are two parts, data and the link. So first you have to access the data and then you will jump to the link part, and then so that you can access the next data, right? So first there is a head pointer. So you will define a pointer head which is going to store the address of the first node of the linked list, which is you must know from where the data is going to start. So head is the pointer. So head pointer is actually storing the value 240, just the 240. And if you know the concept of pointer is actually storing the address. And if you process that part, then you will definitely go to some particular value. If I write 240 inside the head pointer, means when I'm going to go to this particular memory location, I'm going to access this particular value, right? Okay, so first thing is I want to access a head pointer. Second thing is I will define one more pointer, current. Current pointer is used to traverse through the linked list. So this pointer will stay still, you can say, because I might use this pointer to just simply access the first part. As I have discussed before, that you should always know the address of first element, and then you can just go through all the elements one by one by just knowing the address of first element, right? So current pointer will be traversing through the linked list, because we cannot use this head pointer to traverse through all this, because we will lose the actual current address, or you can say the address of first pointer, first value, right? So we'll keep it here, but we are going to define one more pointer to traverse. Okay, so in the beginning we are going to initialize the current with the address of the first node. Means this pointer is also pointing to this particular address. Means head and current are having the value 240, means they are pointing to particular address where the first value 25 is stored. Then iterate through the list, repeat 3 and 4. Iterate means we are going to repeat something, which is step 3 and step 4, and there is a condition, and the condition is saying while the current not equal to null. Means right now the current is having a value 240, which is the address, because current is a pointer simply says the address. So I'm saying keep on traversing, keep on iterating, keep on moving till the current is not having the value null, because we know that in a linked list the last element will be having a null value, right, as a link. Because if there is no value, right, there can be 10 elements, 100 elements, but there will be a last element, that last element will be having a null value, right? So we want to traverse all the values, and when I will reach to the last value, the last value will be having a null pointer, right? So when the current is equal to null, means this is the last element and we need not to traverse further, right? So that's why we are using this condition, that the current should not be equal to null, and if it's null, then stop processing third and fourth part, right? Okay, so next step is process the current data. What does it mean? I said the current is having the value 240, and right now I'm saying current to process the data. See, as I said, a single node is having two things, data and the link. And if you remember the previous video, the memory representation of the linked list, so the this particular value 25, which is an integer value, see, there can be the case the value can be char, any character, any string, anything. So it compiler's job to actually providing the memory locations according to the data type. Now the data type is integer, so compiler will automatically give you the 4 bytes, which is 2. Let's consider here it will start from 240 and till 43. So these 4 bytes are just for the data, and here we are just processing the data from the current. What does it mean? Current was having the value 240, and it will start processing these first 4 bytes, and it will simply read the data. Because if you remember the previous video or the previous one from the array, these any integer type is defined into the 4 bytes, right? These 4 bytes will be accessed, read one by one by the current. Means the current will be having the value 40, 41, 42, 43. It's just the job of the compiler, simply access these values one by one and just read what is written inside these memory locations, right? So this is what we are doing, is accessing the data, and it will reach here. It will simply get the data, that the data is 25, and as we have processed the data, it will simply print it, right? I have not written print here. It's process means just simply accesses and print it, right? Because we are simply writing the pseudocode or in the form of algorithm. So then what it will do next is update current to the link part of the code. Now the pointer was here. Initially it was having the value 40, and it kept on reading the data for the first 4 bytes, and then I said current is equal to current link, means next go to the link part. Means the link part will be having 4 bytes, which is starting from 244. So now the value is current is equal to current to link. So now the value is 244 is here at the current part, at the back of the end. This is whole the compiler work, right? So you just need to understand that the current is actually here at the link part. After the 4 bytes, fifth byte is actually starting the link part, right? So now it is exist, it is going to process this part also, and what it is going to do, it is actually getting the address, right? Because when it processed these 4 bytes, it got the value, that the value here in combining these 4 bytes, the value is actually 25. And when it is going to combine these address and get the value from these addresses, the value will be 250. So now current is having the value 250, that the after that what it will do, it will simply uh, going to as I said, it will going to repeat the 3 and 4 step till the current is not equal to null. Now the value is 250 here, which is processed by the current. Now the processed value 250 is compared here again. So current is not equal to null. It is having something value, right, which is 250. So again it will repeat the third and fourth part. So what it will do, current at this particular location you have to process the data, means you have to jump to this particular memory location, which is 250, right? And you have to process 4 bytes, right, as we did for the first node. 4 bytes will be processed, and the data here access is 11, and then it will go to the link part, means the fifth byte, and it is going to access that part. It will check again here, the current is not having the value null. Okay, so till when, till current is not equal to null. So at the end, when it keep on iterating the value, right? At the end, when it will process here 52, 53, 54, 55, right? After that it will, at the end, third step is done and fourth step is done. In the fourth step the link part is accessed, which is going to start from 456. So here the value is null. If you start from here or process this part, finally the value is having null value. So the condition is false here, so it will stop here. Means that this is the last element or the node. Now you need not to process further, so it will stop. So this is how you will iterate the values from a list. And here you have to start from the head pointer only, because you cannot access any random value because you don't know the address of any node. You just have to start from the beginning, because the first node is going to tell you to which address you have to jump, right? Okay, so if you see the complexity will be big of n, because if you are going to scan the n nodes here, right, for n items, the complexity will be big of n. Okay,